Hello, everyone. Welcome to this perhaps a different Blackboard talk, different for many reasons. I'm Ben. I'm an undergrad here. I study planetary science and also classical civilization. This summer, I've been working at CITA in the summer undergraduate research program, and I got to hang out here and listen to a bunch of talks. A few months ago, there were two talks that inspired me to do a talk on something different. One about philosophy of science and one about the twin paradox. Those two guys are here. And I realized I could do a talk about something different as well. My classic studies has brought me into contact with Greek philosophy. And in my course on Roman literature, I had to read a book, De Rura Natura by Lucretius. I'm like, okay, I don't care about Greek philosophy, but I have to read this for this class. And then I read it, and this guy explained how the universe worked and how magnets work and how earthquakes work. And I'm like, wow, this is pretty neat. And so then I bought the book, I read the whole thing, and then I asked Juna if I could do a talk. And she said that when I walked in, I interrupted her listening to a Greek philosophy podcast, and she was very excited to hear me talk about Greek philosophy here. So let's get started. To also change with the format of this a little bit, I'm going to be doing more discussion because I gave this talk in a shorter form at the Max Planck Institute in Heidelberg a few months ago. I was given 15 minutes to talk. And at the end, I got like 15 questions, and then 5 people came up to me, asked to take a picture of the book so they could buy it, had a bunch more questions. So people are interested in talking about it. And so I'm going to lecture a bit about the history of Greek philosophy, then about Epicurean philosophy, and then towards the end, we can talk a bit more about science and philosophy. So to start, let's introduce Epicurean philosophy. And to do that, I'll give a brief overview of all of Greek history. We can start Greek history at around 1200 BC. Something you are all familiar with occurred here, the Trojan War. At this time, the end of the Bronze Age and start of the Iron Age, we have what is called the Bronze Age collapse. All of the empires in Eastern Europe and Levant, they all suddenly collapsed due to invaders and a bunch of other issues. One of the battles fought in this period was the Trojan War. Talk more about that shortly. For the next 400 years after this, we have what is called the Dark Ages. The Dark Ages, because no one was writing anything, because all the empires collapsed, so there was no administration to be done. So no one was writing anything, so we don't really know anything about this period. But then, in 800 BCE, we get the Greek city-states developing. And because of that, people started writing, and the Greek language developed. And because Greek language finally developed, the Greeks wrote down their stories. For 400 years, the Greeks had the story of the Trojan War as just oral tradition. And so it got a bit muddled. But after 400 years, a guy named Homer, who probably didn't exist, wrote this down. And the relevance of the Iliad and the Odyssey that he wrote down around 100 BC cannot be understated. To compare it to like the Bible or other religious texts for religious groups would honestly be doing it a disservice. Everyone read Homer. Not only that, everyone memorized Homer, had the copy of the Iliad and the Odyssey by their bedside. And so for that reason, in this time period, the education system was fundamentally based on Homer. And of course, in the Iliad, we learn about how Achilles was taught. And there were 2 parts to his education. One, were like physical education. Achilles was a great soldier. And for the folks who wanted to get an education that were part of the aristocracy, this was the ideal. You would do sport, you would do military activities to become like Achilles. But then there's a second aspect of it. Would anyone like to guess what the second aspect is? It's a weird one, maybe. It's music. He was also taught to play the lyre. And this is actually all around Greek mythology. Hercules, for example, was taught, how to fight, but he was also taught music. He wasn't good at it, killed his lyre teacher. But then once the Greek city-state popped up, we get what is called the Archaic period. The city-states ruled by kings. They were warring between themselves. And Greek culture was developing a bit further. In this time period, we get education with these aristocratic, call it knightly roots, moving towards what it would become, which is a feature of the democracy. So what we had originally was individual tutors. People would find good tutors to teach their kids how to be a good knightly hero. But then these tutors got very important because this was a massive industry. They would go around Greece. They would give sample talks of what they could teach your kid, kind of like a ye old Blackboard seminar. And they started to get a kind of divine status because they could teach your kids things like how to convince anyone of anything or how to be a good member of society. These, periods are kind of arbitrary, but they kind of help understand history. For example, 480 BCE was the Persian invasion of Greece that was repelled by the Greeks, Battle of Marathon and all of that. After this period, the Greek city-states reached their highest power, and we have democracy. First in Athens, and this fundamentally changed everything. We have teachers going around giving people sample talks of how good of a speaker you can be in the new democracies. And then there became a focus on rhetoric, the art of speaking. And also, there were other interesting works of literature that came about in this time period, and the Greek language spread. And so an interest in Homer became a more broad interest in literature. Literature and music and rhetoric, these have structure and rules. And when you're trying to convince anyone of anything or demonstrate how intelligent you are, people started trying to acquire really broad ranges of knowledge or knowing a lot about everything. And so people started developing things like philosophy. The reason why this happened is because you had these really relevant, important teachers that were going around and teaching rhetoric to kids because that's what you needed to survive in a democracy. That's the most important thing. Then rhetoric, with its rules and its systems, developed into an interest in other things with rules and systems. And so you get things like math and astronomy and philosophy. And so in general, you lose the interest in physical education and an interest in intellectual pursuits as these individual tutors taking on multiple students turned into really wise people opening schools. You get philosophy. Play a little game. I just want everyone to shout out a person or a place, a thing, a word that they know from Greek history. Just say one. Say a person. Plato, another person maybe. Aristotle, Socrates.
Diogenes.
Yes. All of these folks existed pretty much in this time period, the classical period. That's why it's called the classical period, because in historical terms, classical means best. We got this creation of philosophy in this time period, where the philosophies had one particular goal: operating city-states. Plato's Republic, for example, they had interests in explaining the natural world and things like that. But the primary interest of the philosophy was how to be a proper citizen or how to properly run your city-state, because that was the most important thing. In this time period, when you were a smart guy living in Athens, you were a smart guy from Athens, and that was important. But then everything changed. 323 BCE. Someone know the significance of this year? Essentially, someone died in this year. Okay, guess as to who? Not Julius Caesar. Someone who also might be described as great. Alexander the Great. The death of Alexander marks the end of the classical period and the start of the Hellenistic period. Which literally means the Greek period, because when Alexander the Great stormed through Greece and conquered everything, then stormed through the Middle East and conquered everything, then stormed all the way to India and then turned around and then died of alcohol poisoning, he spread Greek culture everywhere he went. And then afterwards, we had all these large empires controlling these new Greek cities. So the independent rule of the city-states in the classical period was now gone. And so this time period, some wise guy from Athens was no longer a wise guy from Athens. He was a wise guy living in the world. And so the interest in philosophy changed from how to run a city-state to how to reach a state of personal enlightenment of some kind. It started to become focused on the person. In this time period, we get things like Stoicism, reaching enlightenment through the way in which you respond to things, or Cynicism. We had a Diogenes fan in here. Cynicism, it's kind of like being a Jedi. You reach enlightenment by having no material possessions and living a simple life. And finally, Epicureanism. The subject of this talk. I'll explain Epicureanism in a moment, but first, the book that I am getting all my information out of, explain that. This was written a good while later. See, Epicureanism started about here, 307 BC, by a dude named Epicurus, who was born in 340. A couple hundred years later, in Rome, a Roman guy became a real big fan of this stuff, and so he decided to write down everything that they thought into this book. After a while, Epicureanism stopped being popular, and no one wanted to preserve what they wrote down, so we literally only had one manuscript of this book that fully explained Epicurean philosophy. That's the only reason why we know this much about it. This was written by Lucretius, and this is where I'm getting all my information to talk about their science. They like science for a simple reason. Epicureanism was based on literally one thing, one single axiom, and that is that the universe is made of atoms. That is literally it. That's the entire philosophy. There's literally nothing else. Everything is just a consequence of this idea. Consequence of this idea, the universe is deterministic. Mostly. There's an exception. Atoms just bump into each other, and that causes the universe to go. Because of this, there are no gods. Rather controversial thing to say in ancient Greece. God Socrates killed. The reason why there are no gods, because the universe is just atoms bumping into each other. We don't need Helios to carry the sun on a chariot. The sun moves on its own due to something. And because of this, you don't need to appease the god. So how do you reach enlightenment? You do what you want. Seriously, it's this simple. People are happy when they do things that they like. And so to reach the maximum state of happiness, do what you like and don't do things you don't like. It's really that simple because you don't need to appease the gods, right? Of course, it's more complicated than this. This is not hedonism. Don't, lounge around every night drinking wine and eating massive amounts of food. You'll feel bad the next day and you'll have, lasting health effects. That's not sustainable. So you need to be more measured. So it's not just literally do whatever you want. You got to think about it a bit because you want the most sustainable, enjoyable life. They have some suggestions. Avoid politics, seems reasonable. Live in your philosophy school with your philosopher buddies and talk about philosophy all day. Kind of sounds like working at CITA. And that's how they operated. But since they wanted to show everyone that there are no gods and therefore you can believe in this, they needed to demonstrate that the universe can operate without gods. So they needed to explain everything in the universe. So they had an interest in science. They had a whole cosmological model. And everyone talks about their theory of atoms because it's kind of close to the theory of atoms that we had until the discovery of the electron. So let's talk about that. Atomic theory. Okay. The universe was made of atoms and void, where atom are things and void are absence of things. If you have stuff with atoms and void in it, it can be broken down. So if you have an atom, which by definition has no void in it, it cannot be divided. So atoms are fundamental. Additionally, since they're fundamental, they cannot be created or destroyed. Additionally, they argue that the universe has atoms in it. And if atoms are the only thing that exists, there can't be a bound to the universe, because then there would have to be something that bounds it that isn't atoms. So the universe is infinite. Now, here's the cool stuff that people talk about all the time. They get basic ideas of statistical mechanics kind of right. They talk about that things in the world are just atoms randomly colliding. So something, a light in a room, they thought of light as individual atoms. The atoms shoot out of the light, bounce around the room, go to your eyes, and then you see everything, and you see it just average out. That's how we know things work. It's just random processes of things hitting each other. Additionally, they get Newton's first and third laws. They state that atoms can't move on their own, can't stop on their own. It's only the interactions with other atoms that make things happen. And that atoms bounce off each other elastically. Brownian motion. This is kind of good. Some pretty neat ideas here. But it kind of falls apart when you look at how other things work. Like their theory of fields. Uh-oh. How are they going to explain how fields work if all they have are atoms? They don't. Let me explain how they think magnetism works. Would anyone like to take a guess as to how they explain magnetism using just atoms and void? Answer. It's the wind. To the Greeks, the metallic stones were called lodestones. The lodestone would shoot off atoms. Those atoms would move all of the air atoms out of the way. Then you would have an empty strip, and then you would have your iron here. Then the iron would have air atoms behind it and no atoms in front of it. So the air atoms behind it would push it forward. They also described that as you get closer to the lodestone, the difference in the pressure gets stronger. And so, in kind of a weird roundabout way, they got the kind of right ideas of like a potential difference. And they also guessed the 1/r dependence of magnetism. But you may ask, how is it that only iron then moves towards the lodestone and not everything else? Well, how it works is the iron captures air atoms, and then it's like a sail where it can keep pushing it. Yes, iron is a sail, unlike literally anything else that may seem to act more like a sail. This gets generalized. Most things they describe when they're explaining sight, scent, sound, magnetism, light, heat, and gravity are things having pairs that work together. The analogy they use is that you can't get dye out of wool, and you can't unstick two bricks that are put together by mortar, in the same way that you can't unpair the air from the iron sail. They explain everything in a different way. They don't put it all together in one theory, but I call this shedding, this idea, where everything is constantly shooting atoms off of themselves. And then it's the way that those atoms interact with particular other things that give rise to different senses, heat, magnetism, gravity. So for example, I am constantly shedding off atoms, and those particular types of atoms, once they hit your eyes, they pair with them, and that registers as sight. Or other ones will pair with things in your nose to do scent, or other ones will carry heat with them. And other ones, like magnetism. Heat, gravity, magnetism. It's at this point that the atomic theory sort of falls apart. I mean, we know now that the universe is more than just a periodic table of the elements, right? And so clearly they didn't have enough stuff to explain magnetism. So their theory of atoms has to have more to it, and it does. Atoms get their properties from their shape. Believe it or not, to them, the atoms would be things where you might have a hook on it, or maybe they'll be like kind of like grooves or something like that, and that'll make them rough. or it'll have a hook so it can attach to something, and that's where they get their different properties from, and that's how different ones pair to each other. For example, color. Color works by having an atom in a certain orientation with a certain geometry, and when light bounces off of it, that causes a different color. So they did correctly say that atoms are not intrinsically colored, it's the way that light interacts with them. But to me, this doesn't make sense. Because how do all the atoms know to align the same way so that light can bounce off them all in the same way? And how do different things that are made of different materials have the same color? If different atoms get their properties from their surface features, like a hook or grooves or something, so something sticky would have hooks and grooves on it, then how can something be like sticky and red, and also something can be not sticky and red when it needs to be the surface feature that's giving the color? To me, that doesn't make sense. And then I also see problems with how they're explaining magnetism. For example, you can take your lodestone and your iron and stick your hand in between them, and the iron will still move towards it. So clearly it's not, a difference in literally air pressure, because you can block the atoms from the lodestone. So this is kind of iffy. Talk a bit more about that at the end. But here, I'm going to reach the kind of conclusion, the punchline here, the most interesting things, and talk about their cosmology. What I advertised this talk would be about, or the last couple minutes. So here's how they believe the universe works. The universe was just random atoms moving around. No structure. The translation that this book uses is maelstrom, kind of just, randomly flying around atoms. Then some atoms randomly combined to make the Earth. The random collision of atoms. And then what happened was the Earth stratified. First, the heavy things went down to the core, and then the lighter things came up to the top. Obviously, as a result, the moon, the sun, and the stars then popped out of the Earth because they were made of lighter things than the Earth. And then the oceans popped out of the Earth and stayed on the surface. They argue that the moon is heavier than the sun, which is heavier than the stars, because the moon is closer than the sun, which is closer than the stars. To them, by the way, the stars are literally just points, but they do describe them as balls of fire, so that's pretty good. So there's an interesting consequence to all of this. The universe is infinite. Random atoms hit each other to create the Earth. As a result, there must necessarily be other planets. Not only that, there must be other planets with life. The universe is infinite, and there's planets everywhere, and there was no preference to our Earth being created where it is, or planets being in a certain direction. There's no center or no originating side. So in the universe, there's no preferred direction or location. In other words, they guessed correctly that the universe is, on the largest scales, isotropic and homogeneous. When I was reading this bit, because I've seen people talking in other books and online and stuff like that about the atomic theory, that's what everyone focuses on, because, wow, atoms are a thing that we do believe in now. But no one talked about this, when this is really the most important thing that they figured out. Because in no other tradition in Greek history, and basically in none other on Earth that I've seen, but there probably exist, no one guessed this right. To everyone else, Earth was at the center of the universe. People were God's chosen people. To the Greeks, the gods lived on Earth, on Mount Olympus. They were here. The Earth is the only thing that exists. But they correctly realized that the universe doesn't care about us. And for that reason, you can do whatever you want. And that justifies their philosophy. Now, that's the end of sort of the content that I have, but I wanted to move into a discussion. If people have questions, they can also ask now. I'd like to first talk about science, but does anyone have a question?
Yeah, great talk, great. So Right. So I was wondering, just like, did they test?
That's exactly the thing. They didn't really have a means to.
Well, they could put their hand in front of it.
Yeah, they could have done that. And they did have an interest in testing things. So I'll move into the discussion of their scientific method, as it were. Because what they would do is they would say, we observe something, let us create a model, and that model will then explain something. That is the scientific method. For example, for magnetism, they don't explain magnetism right away. They first explained how heat and sight worked, and they said it must work the same way. Therefore, we can say that magnetism works in this way with the lodestone shooting out atoms. So it's actually an extension of their theory that they created from other observations. It's weird that they never tested this though, because they knew stuff about magnetism. They saw that if you had your lodestone and you put little specks of iron, you'll get the field lines going around it like that. They described that. So you think that they would have been able to test putting their hand in front of it. Oops.
Is it maybe that they, like you said, there was this kind of coupling between certain types of atoms? Is it the lodestone atoms just go through your hand and they only interact with the air? Maybe?
That could be it. They didn't explain that in here, but that could be their justification that maybe the lodestone atoms, I guess there's kind of a problem here. If they're small enough that they can go through your hands in a way, then they wouldn't be big enough maybe to knock the air molecules out of the way, because air can't go through your hands. And so that means that they'd have to be smaller than the air atoms. So how can they get the air atoms out of the way? So I don't know.
Was it based on size or is it based on?
Yes, they did describe atoms as having different sizes and that would do different things. And so they would, for example, how darkness worked for them is there would be literally dark atoms that would shoot around the room and knock the other atoms out of the way so you couldn't see anything because they were just bigger than the light atoms.
And you're getting your source is Lucretius. What was his sources? Maybe they did test it and then the data something.
Yeah.
Lucretius is just dumb.
Lucretius may be dumb. So the tradition of coming up to this book 250 years after the models began, there were some letters from Lucretius, from Epicurus that we have. Most of that is lost, and some of it are actually being found in Pompeii. There's the House of the Poet or something. The guy was an Epicurean philosopher, and there's all the scrolls that we can like digitally read, and we're getting Epicurean philosophy from them. So there actually are these debates that they have, and their model does change over time. So let me give an example. In Lucretius, he will explain how the sun sets and rises. So you'll say, okay, maybe the sun goes down, and then it goes below the earth, and then up the other side. Is right. Or perhaps the sun sets, and then it is gone, and then the next day, the ether forms a new sun that comes up. And he says, that one seems weirder, but you can't prove it's untrue. And they would do that for everything. Everything would have multiple little arguments. Maybe it's this, maybe it's this, maybe it's this. And the crucial thing to Lucretius was that he didn't care what the right answer was, because they only cared about showing that there is an answer. And so Lucretius will tell you, maybe the sun goes around the earth, or maybe it disappears or reappears. Who cares what the right answer is? All you need to know is that there is an explanation. And so they would provide multiple arguments, and they will not be married to any individual one. They'd be willing to change them over time. And this is something I'm not too familiar with, but I'm aware that by the time of Lucretius, we have these debates going on, and their arguments change about why different things happen. And so, this is after 250 years of debate is what they came up with. But everything would change. The only thing that wouldn't change is this. Why this would change, because that came from Epicurus and Democritus before him. And so Lucretius, Epicurus is kind of seen as kind of a divine figure. And so this thing absolutely cannot change. But everything else absolutely can. And so my question is this scientific? What do you think? Or how scientific would you rate it? Any thoughts?
Yeah, this is interesting. I'm reminded of that physics seminar, I don't know if you read it a few weeks ago, where there was a guy from Globe and Mail's science reporter, and he was talking about sort of relative journalism-ness of articles. So I feel like there's similarly a scale here on scientific business. there's definitely logic going on, which is not the case in all cosmologies. But yeah, I guess we don't necessarily know how much they really try to test things in space and stuff.
Yeah, we do have other letters and other things, but yeah, I think it's a good mix, perhaps. You know, they probably did better science than Aristotle, who said that all things fall at the same will fall at different speeds based on their weight. But they correctly guess here that in a vacuum things will fall at the same speed, and that it is only the air resistance that'll make bigger things that are the same weight fall slower, stuff like that. So they are thinking more, but they are ultimately still married to some kind of divine influence that they will absolutely not change. So a question that I got at Max Planck, someone asked, did they have any, ideas of having like a whole paradigm shift, of completely changing the model? Absolutely not. It would never occur to Lucretius to change this. He might say, oh yeah, my model of magnetism doesn't work if you can stick your hand in front of it, but it'll work this other way. Trust me, it works. You don't have to believe in the gods. And that was kind of it. And so that's kind of what, obviously we can't compare them to modern scientists because science has developed in such a way. But they were definitely far ahead of the competitors here. Talking about development of modern science, I mentioned earlier that their model of the atom was essentially the model of the atom that we had until the discovery of the electron. Because in a way, Epicureanism was sort of rediscovered in the 1700s by scientists of that period, like Newton, Lord Kelvin, and these folks. So an interesting question for you to think about. Epicureanism died out essentially entirely between 200 and 400 AD. Why did that happen? Another book. What book? Yes, that is absolutely right. Because this doesn't work in Christianity, right? To the Romans, once they became Christian, they were the chosen people. The emperor was God's vice regent on earth. The earth and everything was created for them. It's the only one, all this stuff. Religion has come a long way where things like this are being reconciled, but in that period, it absolutely did not work. But Stoicism, for example, is far more popular today. It has been in history because Stoicism works in Christianity largely, right? Stoicism is reaching enlightenment through the way in which you respond to things. The only thing you can control in the universe is how you respond to it. That's kind of similar to the Christian model, where God has a plan, and then you just have to act a certain way in response to God's plan. And so Stoicism works and stuck around, but Epicureanism died. People still knew about it throughout all of history, and it wasn't until those folks doing science in the Enlightenment and the Renaissance period, like Newton, who started with this. So we know that Newton, for example, liked alchemy and things like that. This was kind of one of his other, kooky interests that these folks in the early development of science were interested in. And so for a really long time, these things were core to atomic theory until like the discovery of the electron. This is what everyone believed in because, they didn't have observations to know that this was not right. It's also another problem they have. They can't observe things, right? Like they can observe things, but they have a limit to what they can observe. If we go back in time, find Lucretius, and show him like scattering experiments and pictures of galaxies and things like that, maybe we'd be able to convince him of something different. But since he couldn't observe these things, he never had a chance to get it right. So a question I have for you, what can we learn from this, what they've done right and done wrong, to maybe influence how we do science today?
Go back to your original
Sure.
question of whether or not this is, or well, you made the claim that they probably wouldn't have been considered a paradigm shift where atoms were not the thing. But I'm kind of wondering if that's true, because it seems the way you presented it, the thing that they care most about is the physical implications of their theory. And I bet I sat Lucretius down and told him everything we do now, he would love that stuff. Right, because you can get the same political implications from what we know as you can from atoms. So is he that married to the idea of atoms, or maybe more married to these other fundamental ideas?
No, I agree. I think if you bring Lucretius into this room right now, I feel like, yeah, folks that are doing modern astronomy are doing exactly what I want, where they believe the universe works as it does. The problem is that even though he was devoid largely from religious things, there was still a religious aspect to this. So I said there's no gods, but that is simplifying it. Lucretius argues that there probably are gods. His argument is that we all kind of imagine and see the gods in our mind. It's common to all of us. Therefore, the gods either exist within our minds, they exist outside of the universe, or they just set the universe in motion and let it be. So to Lucretius, it's not that there is no supernatural things going on. It's just that largely that can be ignored. And for the atoms and void, that came from Democritus, that came from Epicurus, and he refers to Epicurus as a god over and over and over again. And it's hard to change that when, even though he'll say multiple times in his book, oh, these folks who believe in religions are sending you astray, listen to me, he'll also stick with this. That I mentioned before that it was literally only one axiom that defined the whole philosophy was the atoms bit. That was the only thing. And that was the only thing that wouldn't change. Everything else can change. So I also mentioned that the universe is deterministic with an asterisk. The one difference is that, well, if the universe is deterministic, do we have free will to decide to enjoy things? So what Lucretius added, or what Epicurus added, is that the atoms will have a little bit of a swerve. A little bit of a swerve. Instead of, them always just falling straight down or elastically bouncing off something, they might swerve a little bit. And that gives rise to consciousness. That inside us, we can consciously choose the swerving, perhaps, of these atoms, and that lets people decide to do things. And that makes life different from non-life. That's kind of kooky, I think. How do you justify that from looking at the world and how it works, that atoms must have a swerve to them to break from your entire model that gets stat-met kind of right? And that's because Lucretius sort of had these supernatural elements that he had to explain. That, yeah, this stuff wouldn't change, even if perhaps he ought to have. I think that's what we can learn, maybe.
They explain orbits well, for them, Jupiter and Mars would just be stars because
They would be planets.
Oh,
Planet
but-
comes from a Greek word, it means on Earth, because when you look
Sure,
at the
yeah.
sky, the planets move differently from the rest of the
Yes.
stuff. Do you want to guess how they think gravity works?
Is this where epicycles comes from? Because so I'm just making.
No, that's a.
Okay.
So I'll give you a hint. The wind.
Wow. Okay.
How the wind works was it's almost like a fluid surrounding the planet where the atmosphere keeps going and the stars are in the fluid moving around.
Yeah.
And there is some kind of wind, they do not describe its origin or anything. They just say that there's some kind of wind that will push things around. And so, for example, they talk about the motion of the moon and the sun and things like that. So they might say, okay, the sun is, going through the ecliptic, going through the constellations. Maybe it goes through, and then the winds are moving the sun at different speeds from other things, and maybe at different times a year because of like the temperature, the sun and the moon will move at different speeds, and that accounts for these weird motions. Yeah, they didn't actually talk about planets much, about what they actually are. When they explain their cosmological model, they don't explain where the planets pop down and figure from. So I don't know. Don't know.
What about their theory of that they thought there was like some fundamental property of an atom that would give it its colors. But then if you mix colors, like, for example, if you have something that you take this fundamental red, you can see that it creates something that's purple. But then would they say that the atoms have fundamentally changed, or would they believe that? Do they believe in like mixed colors, which mix red and blue?
So it now occurs to me that I forgot to mention something in their atomic theory. That in many ancient philosophies from Greece and stuff like that, where they talked about atoms and stuff like that, and you have one thing moving into another thing, like fire, for example. You might say, oh, the atoms disappear, and we have new atoms reappearing here. They say that atoms can't be created or destroyed. They will change into a different form because you will have a substance that's made of different atoms, and it's the way in which they are structured that gives the total property of that material. And then the analogy that Lucretius uses is that atoms are like letters and you can form words. And then you can have different words with the same letters. So the same atoms can do different things if they're structured differently with other atoms. And so it's about the orientation and the structure. And so they don't mention, what's the color of a compound. But how I would make sense of it, I think, is that if you had two fundamental atoms that were stuck together, what's the color of that new thing? There would be an overall geometry to that shape, and that would give rise to that color, I suppose. Yeah. Any other questions, ideas? Thoughts on how scientifically
You had question about how scientific they are. Nate mentioned do they do experiments? And that is the biggest difference in what
we do these days.
Yeah.
Is everybody tests things the best they can. Your laboratory scientists, you make the system. Or if you're an astronomer, you spend a lot of time thinking about how you would determine the difference between two predictions from two theories, or you build bigger, better, faster, whatever telescope, discover things you've never seen. So now they weren't doing none of that. They were discovering things that people did worry about planets, and they did work out in very great detail how the Earth squinted on the sky. So the astronomers were a lot more like we are than physicists were like present day physicists.
Yeah.
Because they paid attention to the sky extremely carefully.
Yeah, I think when you think about experiments, it's another problem with this. Because they didn't do experiments themselves because they didn't care about the right answer. Instead, what would happen is someone would go and do an experiment or observe something and then say, hey, Epicurus, what you said was wrong. And you would say, oh yeah, that can be explained by atoms in this way. That's the new theory.
So you're just complaining about theorists.
Yeah, I guess so. And I think you can read this and you can really see that some things haven't changed. This really is a physics textbook. I can't say this for certain, but I think it may be the case that in this book is the oldest ever example of someone writing a physics textbook and saying this proof is left as an exercise to the reader. That is in this book. And that should demonstrate really how kind of similar their perspectives are to us now, where he's like, I could demonstrate that this is true. You can think about it for yourself. I don't have time in this book. Which is, the mindset hasn't changed that much in some ways.
So theorists haven't progressed.
Yeah, perhaps that's it. Any other questions? Ideas?
Well, part of this is also probably culture, since all these philosophers were sort of taught in social pattern, as you pointed out. They didn't want to give their hands dirty to someone actually doing it.
Oh yeah, they know.
I mean, because the Greek cities were all around slavery. Slaves did all that, actually did things that allowed people to live.
Yeah.
And so you didn't want to associate yourself with slavery. So you don't do experiments, right?
Yeah, these people led a particularly interesting life. The philosophers of this time, especially the ones that we don't know that much about, they are kind of divine figures. They'll go around telling people about philosophy that they know the answers to the universe or how to reach personal enlightenment, and people will treat them like gods.
Yeah, plenty of that in our
Yeah.
or self-help. Gurus write self-help. People admire them. People write checks. People don't know squat for getting nonsense.
Yep.
So
Same system.
Things have not changed. The other thing is kind of disturbing about this. You call it democracy. They're highly unstable. They almost always fall apart in decades, in tyrannies, and then they cycle back.
Yeah. Here, in the classical period.
Yeah.
So depending on how you describe it, you could say maybe 508 BC or 7, whatever, is when democracy started in Athens. By 323, it was done. Literally less than 200 years at default. So all the time that Athens was in a democracy. And in that time, at least 4 times the democracy was overthrown. Most of those times by the students of Socrates. That's
I would love for you to speak more about how Socrates was actually anti-democratic.
well, he was. Yeah. He trains 3 different people who overthrew the Athenian democracy and was in part executed by the Athenians for that.
He was just asking questions.
Yeah.
Yeah, he would ask questions. That was his thing, right? His thing was, I don't know anything. I will just ask you questions. But it's kind of suspicious when the folks who hung out with him all overthrew Athenian democracy.
What did they favor instead? Generally, they became
Yeah, they would just run it. They would just
people like us fun.
they would just become
They were worried
dictators.
by people attacking the city. You need somebody who can tell you what to do. How to do it.
Heard something about philosopher teams by them. Could be like a philosopher theory.
Well, so yeah, Plato was a student of Socrates, and in his Republic, the way that he described the ultimate republic working was having a philosopher king. Notably, not a democracy. And he was a student of Socrates.
Also, I
Like, really unbiased and person should be enjoying this a lot.
Exactly. That's literally what they say. Yeah.
But it's also notable that none of the texts were philosophers, right? So these people thought they understood how far they did.
No, they weren't particularly good at it because they overthrew Athenian democracy, but would do it for like a few months. And then the democracy would come back, and then a decade later get overthrown again. But they never did a particularly good job. They all got killed like within 2 or 3 years.
Do they have any math? Because I know the Greeks love their geometry, and I think one of my number theory investors, the professor was talking about how the Greeks actually have. Yeah, Pythagoras was up there, but under Epicureanism, did they have like a theory of like numbers or geometry or anything like that?
They didn't care that much. Right, because if you're trying to justify to people that gods don't exist,
Yeah.
is the Pythagorean theorem going to demonstrate that? No, that's just an interesting property of triangles. But what actually is interesting is maybe more interesting than the normal Greek geometry is in here they talk about the universe being infinite and atoms being really small. They have pretty good like ideas of like infinitesimal things or infinite things or comprehending infinity and things like that. They do a pretty good job of that in here. It's saying like, infinite atoms, that's kind of hard to conceptualize. We didn't understand, infinities and how that works from modern mathematics, but they were able to fathom that things could be infinitely small, but you can't see them, or there could be infinite number of things, and that's fine. But no matter. They had no geometry proofs in this book.
So that's another difference, right? An interesting precision.
Yeah.
Which of course mostly has to do with observers, experimentalists. Some theorists have actually learned precision measurements.
These are the ultimate theorists. Absolutely no interest in having any kind of, basis. They just say, well, it must be the case because of this simple measurement.
Also why philosophers tend to have that reputation.
Yeah, because none of the folks that were really philosophers, like some of them had an interest in doing new kind of science. Aristotle's famous for that, but most of the folks that call themselves philosophers that led to school didn't do science themselves. It would be based on something someone else found. Epicurus is a perfect example of this. The idea of atoms being the fundamental thing in the universe came from Democritus in 400 BC. Epicurus just said, that's a good idea, therefore philosophy, and created his school. So he never actually did any science himself. He took the ideas and thoughts people had and then created his school because of it. But he never actually did any science himself. So he really wasn't like trying to discover anything new.
Well, he wasn't trying to deduce.
Yeah.
Trying to explain it.
In service of, you don't need to
Sure.
believe God. Yeah.
He did have teleology with that. That's fine. I mean, his motivations, some stuff don't care. I mean, if you want to know where to suspect their philosophy here, just go through their arguments and see what it makes sense. Some of them did, obviously.
Yeah, no, they did have an interest in it more than, Stoicism and Cynicism come about at the same time. They have zero interest in this. They have no interest in explaining how things ought to work because it's one and done. In Stoicism, you just have to respond to things in the proper way. There's no interest in learning how the universe works because that's all there is to it. That's relevant to the philosophy.
They were addressing questions about
Yeah. But people like it. Stoicism is quite popular, always has been quite popular. These other ones, not so much. But I think in a way, all scientists are kind of having this Epicurean view today. That it kind of resonated with me that like the universe works as it does. And it's interesting to figure out why. I mean, the religious aspect of it, take it or leave it, but the idea of, universe works as it does, we can learn that. That's kind of novel.
They explained asteroids because they thought that everything lighter just flew away from the Earth, or stratified. So how did stuff that was lighter fall back down?
That's really interesting, actually.
People didn't know about asteroids in today's, but they didn't know about meteorites.
Surely they would have known about meteorites, like stuff falling from
They
the sky.
they didn't, at least I don't recall meteorites being in here.
Okay.
Because they would have been aware of it, and they saw like comets and stuff blowing up in the atmosphere.
Yeah.
That was always a thing that people saw throughout history and
Exactly.
prehistory.
Yeah.
I don't know what their arguments are for that because I would imagine in those old times you would have an Epicurean and then like some Plato fan or something hanging out, and then they see a comet pull up in the atmosphere and they're like, God, And then Epicureans, I'm like, I don't know what that is. I don't remember them explaining it. I'll have to look
That's
into it.
interesting.
I mean, like, I've never seen a rock fall from this, like, I've never seen a meteor strike and then a rock, right?
Yeah.
So it just looks like a star. It's like, that star is like, no, I'm out of here. It's
Yeah.
touching the truths.
Yeah, that's what they would see. They would see the streak of the light in the
Yeah.
sky.
So it is a step to go from that to, oh, it's a rock hitting the atmosphere.
So I don't think they would guess it right.
Okay.
Yeah. But I don't know if they had to say, but it's interesting.
I guess one point it has going for it that makes it more scientific is that zealots came and said, let's get rid of this.
Yeah.
Because that happens in science.
Yeah, this was kind of one of the first bits in the European tradition where this is happening.
Yeah. That could keep the spot.
But it was specifically the Christians that killed this. Because this did operate within the kind of Greek and Roman model of the pantheon of gods, because they could argue, you know, gods are in your mind or they're outside the universe or something like that. They're just not carrying the sun on a chair. And so it was able to work in those traditions because people were able to be fine with these kind of beliefs. But for Christians, absolutely not. I mean, nothing in the Greek mythology would stick around with the Christians.
Yeah, that's true. I guess science is dangerous for religion the same way another.
Because in a way, this is like a mini religion where they have their way of how the gods operate and stuff like that. And they ask their followers to come live in their philosophy school and hang out there all day. So like it's kind of a little bit of a culty. They had a bad reputation for that, being kind of culty. And they're not secretive, but since their numbers are particularly small, nobody knew what they were up to. So they were always kind of viewed as like, oh, they're this weird group that just likes doing whatever they want and not respecting the gods. They're dangerous. So they were always not very popular. But once the Christians came around, no chance. They were gone for good.
Thank you, Ben. So good.